Woohoo, we are live. This is Math 40 Elementary Algebra, and we are in 2.6 doing a bunch of word problems, most of which fall into the mixture problem category, all of which can be solved using a chart. And this is another classic mixture problem. And we're moving into problems where you may not actually understand a lot of what's going on, but you still need to be able to figure out, okay, what are the different things that are getting added together? So let's read through. This is a photographer. So this is talking about doing photography where you're developing the film yourself. And in order to do that, you have to run the different parts of the photograph through different types of solutions to get the image to develop. So a photographer wishes to mix 2 liters, so, like a soda bottle, of a 5% acetic acid solution. So in other words, when I say an acid solution or really any kind of solution, I'm usually thinking of something, it's a cool word, aqueous, which means it's a water solution. So basically what we're talking about is we're talking about if this is a little beaker, then we're imagining 5% is the actual acid and 95% is, I'm assuming, is water. So we've got the acid, and I'm not saying that the acid actually sits on the bottom. I'm just saying that's the percentage, right? If we look at it by percentage. Oh, sorry, I took you to Smearytown, didn't mean to. So there we go. 95% water, 5% acid, and we've got 2 liters. And to write liters, you capital L. And then we've got another solution, and this is a different solution. Instead of 5%, this is more. This is a 10%. Now, that's not to scale. That looks like it's like 25%, so I apologize, but you get the gist. Basically, this solution, this picture, it would be a 10% solution. So it's 10% acid and 90% water. So there's less water here, more water here. We're going to add these two together, and we want to get something that sits kind of in between at 7%. And the way to think about this is to imagine that this is a very weak solution. There's not very much acid. This has a lot more, twice as much acid. So we take the weak with the strong and we get one in the middle. Another way to look at it is I'm going to take, I'll write it up here, in terms of, I'm going to go from 5% of the first solution, and 10% is the second solution, and we want to end up with a 7%. So now the interesting thing is that 5, 6, 7, 8, 9. So there's 6, 7, 8, 9. So halfway in the middle point would be 7.5%. And what we're looking at is we're looking at creating something that's a little less than halfway. So there's 5%, there's our 10%. And we're not looking for something that's exactly in the middle, because if we were looking for something exactly in the middle, we just use half of one, half of the other, and we get a perfect average. In this case, we're looking for something a little bit less than halfway. And it's asking how many liters of a 10% solution must be added. Now, this is considered a classic mixture problem because we are literally mixing two things together to get a third. And so I have created part of a chart. And as before, you are not required to use the chart. If you like the chart, awesome. If you hate the chart, skip it and go directly to the equations. So here's the way that I'm going to put the chart together. The first thing to know about these charts is the top left corner is almost always blank. Now, I had teachers tell me I had to come up with titles. I like to put a happy face or something else in there. You can doodle, you can cross it out. I'm not going to use this. what I'm going to do is I'm going to have the different, each row is a solution. So this is going to be the weak solution, which was the 5% solution, acetic acid. And this one's going to be the strong solution. That's the 10% solution. You do not have to call them weak and strong. You could just write 5% and 10%. And then the last row, and this is new for this one, I'm actually going to do a mixture down here. Now, in the previous two problems, we didn't use that. So this is a slightly different approach for a slightly different problem. Okay, so as I go through, I've got a category for amount. I've got a category for strength, and then I've got a blank category. And this is going to be the amount of acetic acid. And I will tell you, if I multiply, and this, when I say amount, this is the total amount of the whole solution. If I multiply it times the strength, I will get just how much acetic acid is. So I would just be measuring the yellow parts. Okay, so do we know how much we're using? And I go through and I see, wait, I've got 2 liters. So I'll start my first percent, my 5%. I've got 2 liters of a 5%. So that's going to be my weak solution right here. And I've got 2 liters at 5%. Now the strength is 5%, so I'm going to write that as 0.05. Okay, let me go to the strong solution. Do we know how much of the strong solution we're going to be using? And the answer is no, we don't. We just say, it just says with a 10% solution, and it said how many liters of the 10% solution must be added. So I need a variable. And I'm just going to go ahead and assume that if we were in the class, you guys would all yell, X, let's use X. And I'd be like, okay. Now, if this is 2 liters, this is also measured in liters. Everything's got to agree. Now, here's where this is a new kind of way to set this up. And that is, I'm going to actually include a row down here that will keep track of my totals. And here I've got 2 liters plus X liters is 2 plus X liters. So notice that I am adding down what we talked about before. Now the strength of the strong solution is 10%. So that's 0.10. And then what's the strength of the mixture? Is it just added? Do I just take 5% plus 10%? Nope. The other solution, let's see, I need a number, a color I haven't used. I'll use purple. 7% solution is the mixture. So this is going to be 7%, which is 0.07. Notice that you don't add percentages. Don't add percentages. And then what was the other color? Green. That's this one, the strong solution. And this one is the weak solution. Okay, let's get this all color coded. So now I claim if I take 2 liters times the strength 0.05, I will get how much acetic acid is in there. So I'm going to take 2 times 0.05, and I'm going to end up with 2 times 0.05, and I'm going to end up with 0.1 liters of pure acetic acid. So out of the 2 liters, I've got a whole 1/10 of a liter of just the acid, the acetic acid. Okay, let's try this one. I've got X times 0.10. Well, now it's impossible for me to know without knowing X. So I'm just going to write it as 0.1 times X. And then the last one, I've got 2 plus X. That's my total amount. and it's 7%. So I've got 2 plus x times 0.07. And the way I'm going to write it is I'm going to write the 0.07 out in front like I did there, but I'm not going to multiply this out yet. It's 0.07 times the quantity 2 plus x. And each of these is in liters. Okay, there's my chart. And I know if this is the first time you're looking at this, this is probably overwhelming. The good news is that these chemistry type problems where we're mixing strengths of solutions together, they all end up working out the same way. So we're going to practice a couple of these. We're going to practice this, and then there's a slightly different version where we talk about coffee and tea. And I'm going to try to convince you that they're basically the same type of problem. So we're going to get lots of practice, and then you'll get practice in the homework. Woohoo! So now we've got a chart. We've got a drawing. You do not have to do the drawing. We've got this weird thing up here that I didn't really explain. We'll come back to that. We've got this chart, which you're like, what does that tell me? And I'm going to remind you, the way we set up mixture problems is generally it's formulas that multiply across the top, and then results that you can add. So I'm going to take just the last column, and I'm going to write it out as an addition. 0.1 plus 0.1x equals, so these are the two solutions we're mixing, and that equals 0.07 times the quantity 2 plus x. That's the mixture. So we add the weak solution to the strong solution, and we get the mixture. Okay. Now, the way we're doing it in a very sneaky way, because here we were adding the total amount, but what are we doing over here? We're just adding the acetic acid, just the yellow bits together. So it's kind of an interesting way to look at it. Okay, so if I've got an equation, I should go ahead and simplify over here. So that's the next step. I'm going to multiply through. 0.07 times 2 is 0.14, and then plus 0.07x. Then I'm going to look at this and I'm going to say, okay, where do I want to move the x's? And between these two, I think I want to move it over to the left. So I'm going to subtract 0.07x from both sides. So take a look, make sure I did that. Now, a lot of people would say that this has to do with 6. Notice that 0.1 minus 0.07 is 0.03 because this is actually 0.10. So be really careful if you do this one by hand. Okay, and I'm going to subtract 0.1 from both sides. And I'm going to end up with 0.03x equals 0.04. So 0.03x equals 0.04. And then my last step is going to be divide 0.03x all over 0.03 equals 0.04 all over 0.03. X equals, and this one I'm not going to try to do in my head, 4 divided by 0.03 equals, oh no, 1.3 repeating liters. See that? It's 1.333. And I happen to know that that converts to 1 1 liters. So we've got another option. Okay, so let's take a look at what we just did and let's see what we think. Kind of woohoo. Did I answer the question first off? How many liters of the 10% solution must be added The 10% solution is right here, the green line, and that is X. X is how much? So this one is, I can put a box around it. That's my answer. Now, a couple things. One thing that I did, and it was a split-second decision, and this is that thing that happens if we were in classroom together, I would say, hey, are you guys up for doing this all with decimals? Because if you want, we could clear the decimals. We could actually do it without decimals, and we could do it so that it was with whole numbers instead. And so what I'm going to do is, rather than to do the whole thing over again, because this video is going to be very long. I know my cat is so excited about math today. This video is going to be so long already. I happen to already have a version of this. Let me show you. This is a version that I have already done. And when I got to, let's see, when I got to this stage right here, 0.1 plus 0.1x equals 0.14 plus 0.07x, right there. Notice what I did in the very next step. I went ahead and multiplied by 100 in each case. Let's see, what color did I not use? I didn't use pink. So I did 100 times each term, and I cleared the decimals. We're clearing the decimals there. And so once we solve it this way, it's a lot easier to work with. You're not working with decimals. So I will include this in the PDFs. And obviously, right now, if you'd like, I'm not going to walk through it, but you can go ahead and take a, you can take a screenshot of this, pause the video and take a look at it. So this could also be a way you could solve it. I chose not to because I thought that the numbers weren't that bad until the very end. Then it was like, oh, that's right. Okay, so let us look back now at this thing I wrote at the top, because if I were you, I'd be like, yeah, what was the whole point of that? Why did we even do that? And the answer is, it's a way to estimate. If I'm going to mix 5% and 10% and I want to end up with 7%, that is a little closer to 5 than it is to 10, which tells me I need a little more 5 than I need of 10. So how much of 5 did I use? I used 2 liters. How much of 10? That was the X, 1 1/3 liter. So this is a way to estimate whether you got the problem right. And I would say, yeah, because the second amount, the 10%, is a little bit less. Yep. The 5% was more than the 10%. So you can kind of do a little estimate check, because otherwise, these kind of problems that are like the chemistry problems, they are hard to check. I don't know a lot of people who are brand new to this who can estimate whether or not, whether this is a good answer. So I think one of the things you can do is decide, is it close? And the answer is, yeah, it makes sense. So at the very least, it makes sense. Okay, having done that one, let me show you one that is very, very similar. And again, when you're just starting out, I'm not sure if it's clear that these are similar, but this is, I'm going to claim, almost identical to the one we just did, which is going to sound goofy. A store sells regular coffee for $8 per pound and gourmet coffee for $14 per pound. To get rid of 40 pounds of the gourmet coffee, a shopkeeper makes a blend. The other word for blend is mix, so this is a mixture problem, to put on sale for $10 per pound. How many pounds of regular coffee should he use? So shall we give it a try? I'm going to put a happy face there. I'm going to start with the things that I'm mixing together. I'm going to put down here the blend, and you could also use the word mix or mixture. What are the two things he's adding? And I think the two things are regular coffee. So that's, I'm going to put right here. And then I'm also going to mix gourmet coffee, or he's going to mix gourmet coffee. So that's the second part. It's going to be gourmet coffee. So first off, just knowing what's getting mixed is important. Then across the top, this is how you're going to remember it. The first one's going to be the total amount, which was, where did it go? Just like previously, total amount. Now here, it was strength. Now we don't have strength here. We have cost per pound or price per pound. And if this is the total amount of coffee and this is the price per pound, if you multiply these two things together, you get the total cost of the coffee, a big bag of coffee. If you want to buy all of it, how much would it cost? So let's look. For the regular coffee, does it tell us how much we have? If I go through, regular coffee tells me $8 per pound, so I can put that in here, $8 per pound, and pound is written as LB if you want it short. Okay, and then gourmet coffee is $14. I can put that here, $14 per pound. Let me identify that. The regular coffee is $8 per pound. The gourmet coffee is $14 per pound. Okay, to get rid of 40 pounds, so we got an amount of the gourmet coffee, 40 pounds of gourmet coffee. Okay, so 40 goes right here under the total amount. That's pounds. A shopkeeper makes a blend. Okay, this is interesting. So now we've got a third piece of information in here. I'll use yellow. Makes a blend, and the blend is put on sale for $10 per pound. Okay, so this is going to be the blend, and that's $10 per pound. So we're slowly collecting information. I think I've used up all the numbers. I double check. Let's see. I don't know how much regular coffee, so let me go back over here. I'm going to go to the last sentence. How many pounds of regular coffee should he use? If that's the question, that's what we're looking for. Usually the question is where the variable is. So that's my variable. And just for fun, I'm going to call that C. And that's going to be my regular coffee. You can go for X. I'm just going to try to encourage you to use other letters too. Okay. If this is C, and that has to be in pounds because this is in pounds, and that's 40, how much total do we have in the blend? Remember that we're adding down. And the answer is C plus 40, right? You add coming down. Then as we go across, we're going to be multiplying. C times 8. C times 8. Usually we write it with the number first, 8C. Okay? 40 times 14. Well, I can actually work that out. Some of you could probably do that in your head. 560. Okay, and then this one's going to be a little bit more persnickety because this is C plus 40. So it's C plus 40. I need to put that in parentheses times 10, which I'm going to write 10 times the quantity C plus 40. Okay. Now, what has to work for this? And the answer is, for all of this to fit together, when I add down on this side, it's got to be true. So in other words, the total cost for the regular coffee plus the total cost for the gourmet has to equal the total cost of the blend. So in other words, that looks like this. The total cost of the regular is 8C. The total cost of the gourmet is 560. And the total cost of the blend is 10 times the quantity C plus 40. Woohoo! So now let me go ahead and start solving this equation. I've got 8C plus 560 equals, and then I'm going to use the distributive property, 10c plus 10 times 40 is 400. Now I'm going to think to myself, okay, where do I want to put the c's? There are actually more c's on the right, so I'm going to move them over there. I'm going to subtract 8c from both sides and get 560 equals 2c plus 400. Then I'm going to move the 400 over. So I get 160 equals 2c. And then I have to steal some more paper. Make sure you have lots of paper around for word problems. They take a lot of paper. So I've got 160 equals 2c. And then really all I have to do for this is just one more step. 160 divided by 2 equals 2c divided by 2. So 80 equals c, or c equals 80. So let's look at what was c to begin with. I remember I picked c for coffee, so it tells me something about coffee. It's the total amount in pounds of the regular coffee. So I write pounds. Let me double check, is that what I was looking for? How many pounds of regular coffee? And the answer is yeah. I'm looking for the regular coffee, and that is this amount. So that's what I wanted. The C is my 80 pounds. Woohoo! Now, can we do the same thing we did with the previous problem where we did this guy? Let's take a look. So if I have this, the regular coffee is 8 and the gourmet coffee is 14. Sorry, I should make this straightened out. Sorry, it's as straight as I get today. I'm going to start at 8 and I'm going to go to 14. So let's see, halfway in between is going to be, believe it or not, 11. 9, 10, 11, 12, 13. So this is halfway is 11. And what am I looking for? I'm looking for 10. That is closer to the 8. So closer to the 8, which means it's closer to the regular coffee. So I want more regular coffee, less gourmet coffee. So this is the regular. This is the gourmet. And the 10 being closer means I should use more of the regular. Is that what happened? I used 80 pounds of the regular and only 40 pounds of the gourmet. It worked. Woohoo. Okay, as much as I hate to do it, I'm gonna have to cut this video because it's almost 30 minutes. That's really long. And so what I'm going to do is I'm going to stop this video here. We've got one more problem. It's very exciting. Look at it. It's a scuba diver. It's very exciting. So I'm going to stop this video and we'll come back for scuba diving. I know everyone loves scuba diving. Yay, let's hear for fish. Yay. Maybe we could even bring out the shark. Ooh. So I will see you guys in the next video. Math on, guys. Math on.